And we are recording. Welcome to the evening of Python coding. We have a very interesting library today from Kung Fu AI. So this is a local Python shop, actually machine learning shop that uses Python, and local to Austin, of course. For the DC people here, well, you have to come visit them. But there is a representative from DC. Uh, our representative from Kung Fu AI is Michael Wharton. I hope I'm pronouncing the last name correctly. And
nailed it.
Thank you. And the library that they are providing is an open source library. It's called dynaparse. And I believe Michael will explain it much better than I can. So Michael, go ahead.
Thanks, Jacob. Yeah, thanks for having me here today. I'm going to try to keep things as casual as possible. So I know we mentioned this before, but feel free to interrupt me, send a note in the chat. I'll try to keep an eye on it as well. I know Andrew might have said he'd look at it as well. But in the chat, I'm going to send a link to the kind of the bones of what we're going to be building on to just demonstrate the functionality of this library. So if you want to code along, get your feet wet and type, feel free to do that. Or if you want to just hang out and watch, that's cool too. So let me get my screen share set up here. It's there. Let me know when you guys can see it.
You
just need one.
All
right.
Fine.
Yep. Cool. Well, I will keep this. I'll try to keep the background abbreviated so we can spend more time on the fun stuff. But just a little bit about myself. I am a principal machine learning engineer at Kung Fu AI. My background is in aerospace engineering and computer science. Recently I've been doing a lot of AI naturally, but in my background, I worked for SpaceX for about 4 years doing test engineering, data analysis, and actually a little bit of mechanical engineering. I also worked at applied research labs here in Austin doing a lot of remote sensing work. So think, space-based platforms, satellite imagery, airborne LiDAR sensors, anything where you're collecting data from a distance that's physical data. That was the kind of application we were working on. But for the last 3 years, I've been here at Kung Fu AI. And I put in the marketing spiel about what we do here, but essentially we're just an AI consultancy. So and I think this background's important to kind of explain the birth of this library. We are strictly a consultancy. We're platform tooling and, environment agnostic. So we can't afford to really embed ourselves in one stack because we have one client that might dictate, us to use a certain stack. And the other client, they might have completely different needs. So a lot of the tooling that we build is generally pretty generalizable. It's not embedded in one stack. And that's kind of a little bit of the background about where we come from when we're trying to build internal tooling. So this library, dynaparse, that I'm going to talk to you guys about is, it helps us with parsing configurations and arguments for scripts. And the only two things that we found that we're guaranteed to have from project to project are access to Docker, which is kind of the de facto standard. Everyone uses containerized deployments. And we also have access to bash script, some sort of bash terminal where we can interact with a Linux file system. And beyond that, not much else is guaranteed. So we end up wrapping all of our business logic in these containerized deployments that are called from bash scripts. And we call them, you naturally get a string of arguments that you have to call it with. You might want to run with different parameters. The use case that we had in mind in building this library is that when you're training a machine learning model, there are a lot of parameters that are common amongst all training runs. So epochs, batch size, learning rate, etc. They're all really broadly applicable. And then there are these other modular configurations that you need in certain use cases, like, maybe one architecture you're trying to build out. You're trying to refine your hyperparameters. So you need to tune layer sizes, you need to tune data paths, all sorts of stuff that's kind of like a modular corner of the performance tree of this script. And if you're not that familiar with machine learning, that's okay. I'm going to go into a lot more detail here shortly, but an alternative example that I'm sure a lot of us are familiar with are the ETL. You have an ETL pipeline for some data that you're cleaning.
Tell the people who don't know what ETL is, what it means.
All right. ETL is extract, transform, and load. It's taking data in one format in one location and doing stuff to it, munging it, and then putting it somewhere else that's more accessible and some expected convention. So you might take a CSV file and load it into your Postgres database. That could be, an ETL pipeline. But a lot of times you'll have the core bones of a script where, things like extract, transform, load, these methods, the parameters for that are common, but then you might have different arguments for whether you're processing like images or tabular data or text data, anything like that. So it's a lot of words. I think it'll make a lot more sense when we actually start putting our hands on the keyboard here. But I think it's important to note the possible solutions, because I'm sure a lot of us, if we've built scripts with arguments, have probably done a combination of these things. The first obvious solution is you just make a giant script that has all the arguments that you need, whether it's, your processing pipeline A or B. And this is naturally what I kind of tend toward. But the problem, especially if you've tried this before, I'm sure you can empathize with this. That script ends up being very unmaintainable. It gets very bloated, and you end up with an arg parser that has, a list of arguments that are a mile long. And in any given run, maybe you're only using 15% of those. And there's a lot of bloat and dead weight that just gets carried along with the script that you're running. And there's also a lot of cognitive overload when you're trying to intuit what someone else might have done. And then the other option here, or another logical option, would be you just have an arg parser for each script. So let's say you're parsing one script, and if in the training example, epochs is just one argument that you set it to 50 or 60. And that same argument you might have in the other script with, its own set of arguments. But at that point, it's going to violate the don't repeat yourself principle, the dry principle. If you're not familiar with that, it's basically saying that in programming, it's kind of, it's not best practices to repeat a snippet of code that's doing essentially the same thing in multiple parts of, your application. And anytime you make a change to one, it's not going to automatically get propagated to the rest of your code base. So in every step of the way, if you can not repeat yourself, you end up with really elegant, clean code. All that said, this thing that we put together is meant to solve that problem where you have a core functional, lightweight script that does something, and then you want it to behave in kind of a modular way. So dynaparse allows you to switch that modular behavior depending on the variety of this script that you're running. Maybe it's one pipeline or another pipeline, but dynaparse allows us to do that. And this is the last of the boring slides, and I promise we'll start writing some code. If you want the TLDR of this, and please don't fret if you don't understand some of this. For those that are familiar with argparse, you create an argument parser just like you would otherwise, but instead of inheriting from your standard vanilla included default library argument parser, you just stick in this dynamic argument parser instead, and then you unlock all the functionality of this library, which we will go into here shortly. So I'm going to pause there and just stop for questions, comments, concerns, anything anyone wants to talk through about the background before we start writing some code.
Dynamic parsing versus static parsing, how does that compare with asynchronous and synchronous engineering?
That's a great question. Do you mean asynchronous like requests or processing or multi-threading?
Yes.
Yeah, so we actually don't, there's very little we end up doing async unless we're wrapping some of our deployments in a prediction server. So very little of this was built with any sort of asynchronous programming in mind. That said, I can't think of a reason that this wouldn't be pretty compatible. So maybe we can flag that, and as we're building it out, if something comes up that we can kind of talk through in the context of your application, we can kind of suss that out as we go.
Thank you.
Yeah, thanks.
For the simple people, say a few things about argparse, because we have Python programmers who are just beginners. Explain to them like arguments, basically.
Yeah, this would actually be a great time for me to just bring up my terminal
Okay,
and,
good.
and show some arguments. So for those that are familiar with the Linux command line, this ls command is really common. It's just to list the files in a directory. So if you want to list all files, including hidden ones, you add this argument -a, run the same thing, and then you see that there's a hidden Git folder. So that means this is a Git repository. There's some special Git file here for ignoring certain formats of files, but arguments are used in scripts to change the behavior in some way. So yeah, ls-a, that's a pretty standard one. But argparse in Python allows you to take your script, pass in these arguments that are called from the command line, and then have them available in whatever way they were specified to your program, parsed and typed and ready to go. So if this isn't a script I have, but let's say you have a script that's called run ETL, and you have this argument that's like a data path, and you give it path to my data, and then you run this script. What the arg parser allows you to do is take all that stuff that the Linux command line understands, but Python doesn't by default, parse it, and then turn it into a Python object where you can access that data path in a dictionary or some other Pythonic way of accessing data so that you can use it elsewhere in your script. Does that make sense? Any questions there?
No, perfect. But
all right,
go on. We'll see it from inside Python soon.
All right. Yep. Well, here we go. I wrote a little arg parser here in the canonical way that you typically parse arguments. It's this, it's built into Python. Just by having a Python 3 installation, you're going to have this arg parse library built in. So it's free. You have this arg parser, argument parser you can import. And what you can do is create a class, inherit from this argument parser. So those that aren't familiar with inheritance, you have an object that behaves a certain way with a bunch of logic in it. Someone else made it over here, and you want to take that functionality and build on it. Maybe you have a base class of like a fruit, and you have methods like get color or get size or get weight. And then you want to build on that to add some sort of pricing methods like get price or increase price. Then you would inherit from that base class fruit. You'd add your business logic to it. And then you'd get this thing where you get to, rely on someone else's code for free and then add only the little bits that you think are interesting. So that's essentially what we've done here. This is a very common pattern in Python. If you're writing a script, you inherit from this argument parser. And in this init method, you tell it what the arguments are. This you don't need to worry too much about. This is just the first line here is just defining the name of the program, something that's a description that tells what it does. But this is just a dummy arg parser where I've added one argument. I've said it's our learning rate, and I know that it's a float type. I want a default available just in case someone doesn't specify it, but I want something that's a likely default. And then I have a help string as well. And what I've done is I have this program. It'll initialize this parser. That's what's happening here. It'll parse the arguments and stick them in this object here called args. And then the way I have this script set up, it'll print what the script sees at the command line, and it'll also print the arguments. So let's go ahead and just run it so you can see it in action. You see it went through, it said, okay, I only saw the call to this script at the command line. And then the arguments that were parsed out, it found a learning rate, and it didn't see that I specified it at the command line. So it put its own value in there. So let's say I'm running the same script, but I want to put a different learning rate. Maybe I want to do 0.05 instead, which is a really large learning rate. Then you see at the command line, at the outset, it sees this raw text that's coming from it, from the command line. And argparse allows us to parse all that out and have it available in a namespace where my downstream code, I just say args.learning rate. If I look up what the value of that is, it's going to be whatever was supplied at the command line. So writing scripts is very common. You'll see this all over the place. And if you just Google argument parser, if you're not familiar with it, arg parse, this is a very canonical thing. People do it all the time. And it's really convenient for when you want to wrap any sort of functionality you have in a command line utility. So I'll pause there before going any further. Does that all make sense? Any questions?
Go on. This is great. Thank you. It's like you're explaining. We have a mixed audience here typically, so touching upon the basics helps. Thank you.
Okay, great. That's good. One other really great function of the built-in argparse library is that you get this help method for free. And it takes all of this information that you supplied before, including help strings for your arguments that you added. And it, just like any other command line utility, it'll say, you call the script, you set your learning rate, there's this help method, and then it tells you what the defaults are and gives you just a free, useful help builder that you don't have to think about. You just build your thing and it's generated for you. So let's say we wanted to add an argument here that was, let's call it myInt. And let's tell it that it needs to be parsed and typecast as an integer. And let's say the default's 5. So now, sorry, I'm fat fingering a bunch of stuff here. So I saved it. We just ran it again. Now you see it has this other argument that it's that we can configure for the script, and prints out the default. In the same way as the learning rate, we can say myInt, give it a new value. See, it gets parsed out and passes that through. It's just a really, really beautiful, awesome tool that allows us to parse these arguments and go off to the races with our scripts. So now let's see what dynaparse does. What this allows us to do is, in the same way that we imported this, I need to get rid of these tooltips. In the same way that we imported this argument parser, we will import a dynamic argument parser instead, and we inherit from that. And then, as I mentioned in the slideshow, by default, that unlocks everything that we have to offer in terms of this library. And if you just inherit from it and leave every other line the same in your script, let's go ahead and run this one. Dynaparse demo, run. Let's do help. You'll see this is the exact same script we were dealing with before, except this line changed here, and we had this import. But now, in addition to this learning rate, we have a few special goodies that get added to it. There's this spec parameter, there's a config, and then there's this random sample flag, which we're still building out the functionality of that, but I'll go over that here shortly. And those get added, they're reserved words now, and they allow you to, in the most basic use case, append JSON configurations or YAML configurations to your arg parser without having to worry about defining everything in your script. So I'll give you an example of that. If I run this dynaparse demo and then let's see, run without any help, you see it didn't have any config, no random sample, and no spec, but it's still got that learning rate here. I have a couple of just super basic YAML files that I put together with dummy values. You see this one's just YAML file with one argument that's a list of integers. Another one that is just the value of pi. And the second one, you see it's got a string argument. It's got another float here that's nested. And it's just, if you've seen a YAML file, you've seen stuff that looks like this. And what's really cool is often in the machine learning world, these configs are, they take a lot of work to put together for a model configuration. And people have already built these out and shared them on their own open source repos. So it's a lot of work to adapt your script to be able to work with their arguments. But instead, what dynaparse allowed you to do, let's just say this, we'll do run, and we'll specify a config here. Let's give it config sample1. And now what it's done is it's added all the arguments that are contained in this YAML file. It's appended it to this arg parser, and it's given us these values. It'll infer the type. It'll stick it in a namespace for you. And now instead of having to go through all the trouble of adjusting your arg parser, adding all this stuff, trying to adapt your own logic to kind of cater to someone else's consistency, conventions, you can just point to the YAML file and you're off to the races, and you have that available to your program. And another cool thing about this is, let's say we call help. It'll infer a lot about what you have under the hood just based on this YAML file, and it'll append that to your arg parser. So you see there's no help configured because we haven't configured anything, but it assumes that the current value is a default. It adds it to your script. And then if I wanted to, I can just, append to this as I see fit. So I think that's another good place to pause before going too crazy here. Some of you might even find that function alone is something that might provide some utility. Maybe not, but that's a good checkpoint here. Any questions?
This is good. This is very, very nice. Yes, already. So let's start this. The sample file, the YAML file that you configured, is basically parameters that you didn't define in the program explicitly. What you're doing is that you're defining them outside, and then you're kind of asking the system, import it as if I wrote code to have all of those as arguments. Am I correct?
Yep, that's exactly right.
Okay, and the next question is how do you define the help? No help configured.
That's a great question. That's the next part here.
Okay.
All right, you're getting ahead of the class.
I wrote so many of those.
It's clear, yeah. So what you might want to do in some cases like this, maybe down the line you do decide that you want to just explicitly define all those arguments, put it in your source code. Your logic is kind of stabilized enough that it's worth taking the time to do that. But let's say you're still kind of tinkering with things. You want to get this functionality without you changing your source code, specifically configuring help strings and defaults and all that. What you can do is when you pip install dynaparse, you just install it like you would any other pip package. You get access to this command line utility. And what it does is, let's say I inherited some JSON configuration or YAML configuration from someone else's application, and I want to adapt it to my own use case. You just run dynaparse init, and then you pass whatever other YAML file it is that you're pointing to. And you'll see it says two things. It writes an auto-generated config file and an auto-generated spec file. The config file, if your input's JSON, it's just going to output as JSON. It's basically a copy of the file. But if it's another one of the supported formats, it's going to adhere to this convention of JSON configs. So you see now this is just a JSON version of this YAML file that we had as input. Nothing's changed, just a different file format. And then you get this auto-generated spec as well. And what it does is it allows you to define, these. There's a reference that's on. If you go to our, let's see, dynaparse. Make this a little bigger. If you go to the home page on GitHub, and you go to this spec reference right here. Let's see. There's a README in here. There's a guide on how to configure these spec files for your own use case. So there's all sorts of supported types there, but it's a lot of the basic ones you'd expect, like integers, floats, booleans, lists, and strings. There's also this categorical type where, let's say you want to select between three options. and you want this program to error out if someone provides something that's an illegal flag or illegal option, that functionality is built in as well. So let's, oh, go ahead.
Go back, please. It's a little bit
Sure,
fast.
sure.
So it's like you generated this automatically?
This is a reference that helps you build these spec files. So let's say you wanted to build a categorical argument and you only wanted it to have a value of 1, 2, or 3 or something like that. You would use this guide to help know which keys you need to put in this spec file to get the functionality that you're after. Does that kind of make sense?
Dictionary. This is the dictionary. I thought that the system built out the documentation in HTML. This is.
Oh, no. This is just a markdown file that I put together that it's just a reference tool. Yeah.
Yeah. Thank you so much. I appreciate it.
Absolutely. So let's go ahead and just make this spec file a little more interesting. Let's say we want to add some help here. We say this is a help string, and then this guy will just say, foobar, hello world. We can define whether it's required, all sorts of type information. And here's another interesting one that we'll work with. Let's say, I'll go into more detail about what this is signifying here. But for now, I'm just going to put in a couple values. So now we've presumably configured this to our use case. Let's just call this spec.json and rename this one to config.json. Now we'll go back to this base script that we have that's, it's got arguments defined that are common to every use case that we have. And then the more niche modular functionality gets defined in these JSON files. So let's do dynaparse demo, run, and let's point it to the spec file and call help. So now you see it's got this is the help string that we just put in that file. It's got all this other stuff. Still got the same defaults, but now we can take this one script, if we don't tell it that spec's important, now it's just got these basic arguments that were already in there that it parsed and, they live in our source code. But there's this one use case where we want to behave a little bit differently. So then we just point it to the spec file, and then we get all that added functionality for free. So let's call it once with the spec file. You see it automatically just put these defaults in that were defined in our spec file. Let's say we want to change the value of this config1 arg2, and we want it to be 1, 2, 3, 4, 5. Did I spell it wrong? Config1. Oh, CF1. That's why. There you go. And now it passed that argument in. It knew how to handle it because we told it that in this use case, in this configuration, we want it to behave in this, this particular way. And another thing that's really cool I think that's useful for our use case in particular. Those of you that aren't data scientists, this might not, pique your interest that much. But what I did by defining these additional parameters is I defined a distribution that we want to sample this parameter from. So if I say now random sample and I run this thing, it's sampled from that Gaussian distribution that I defined there, and I can run it again. I'll get a different value that's sampled from that same distribution, but presumably if you're running Monte Carlo analyses or hyperparameter tuning, or you're doing something that requires you to change values frequently, but within some constrained way, this part of it is actually kind of useful. You could also just totally ignore that and not care that it's there and still get all the other functionality. But if you're on the data science side of things, you might find that kind of intriguing. So that is how these specs work. And I want to just reiterate that, you might find that just pointing to JSON files all day without even caring what the heck a spec is, you still might find that useful. You could do that all day, point to a YAML file and not have to change your script, but still be able to take in someone else's configuration that they had defined. So that alone you might find some utility from. I think that's another great place to pause. I'm hearing crickets, so if I'm moving too fast or if there are any questions, let me know. So I've got just a little more.
Can you explain I'm more on how dynamic parsing works with design patterns or interpreter patterns?
Mm-hmm. Yeah. So just a little bit of my background. I'm the best practices software engineering side is something that's I'm still kind of a novice on. So we are an object-oriented programming shop. A lot of what we do kind of relies on Martin Fowler's clean code book. Those are the kind of our aspirations. So a lot of the design patterns we end up following are very in line with the what he's kind of laid out in those in that book. So
Which
you'll
book?
see it's called Clean Code.
Clean Code.
It's yeah, if you've heard of Martin Fowler, he's kind of like the godfather of just really well documented design patterns and best practices. I think he was the one that coined the term code smell. So if you're, a lot of what we build is kind of in line with that. So the design patterns we followed for building the library are very object-oriented in nature, solid principles, that kind of stuff. But for the way that this is implemented in your own library, it feels a little bit flexible. I haven't actually thought too much about it.
Real good.
But,
thank you.
yeah.
Thank you
Yeah.
so much.
Absolutely.
It's actually, I cannot say a specific design pattern, but it's a good point for a little bit discussion. But some of the design patterns that I use are actually using those configuration files, and this is exactly the tool that you're targeting this tool to help with this.
Mm-hmm.
It's like exchanging those configuration files. I don't know exactly what. I haven't read the book that you're talking about, but they must have something to do with the exchangeable inputs or something.
Yep. Absolutely. Well, cool. There's just a little more. Let me check my checklist to make sure I've gone over the interesting bits. All right. So yeah, this last little bit, we'll open a Jupyter notebook and I'll show you one other feature of this API. So I have, if you end up running this at home, this requirements file here, the only thing you need is just dynaparse and a Jupyter installation. So I'll call Jupyter notebook. It should pop me into a server. Went to the wrong window, so let's fix that. And I'm opening this. All right, so a lot of you, I'm sure, have written something to read JSON files. It's import JSON with open file name, read as data equals JSON.load FD. If any of you have used this pattern to load a JSON file, you might find that this library just helps you load things quicker if you need to. It'll save you like 2 lines of code. But if you are not as interested in the command line use case, but you still want to do some of this additional parsing behind the scenes, what you can do is import this dynamic configuration object and pass in a YAML file, a JSON file. If there are any other supported formats that you guys might be interested in, feel free to just put in an issue or a feature request, and happy to build that in for you. But I'm going to go ahead and open. I created 2 dynamic configuration objects just by sending in a YAML file. And now what you can do is, you can get the values. And let's go to, let's see, you can pick 2 get values. Yeah, this one's interesting because there are nested values. And by default, it uses this dot syntax to just flatten everything into a flat tree. But you can also do this expand equals true flag. And then that'll give you a nested dictionary that mirrors the exact structure of your underlying JSON configuration. So you might find that using this API might save you, a couple lines on reading JSON or YAML files. Or it also will allow you to not care whether you have a YAML or a JSON file under the hood and just point to the file name, and all of the interface is consistent after that as nested dictionaries. Another thing you might want to do is, merge configurations. Maybe you want to merge a couple JSON files and you don't want to do the pain of, trying to find some other hand-rolled way of doing it. We can say config3 equals config1 dot merge with config2. And now, if you run that same get values command, or let's go ahead and expand it on this one, you get all the arguments from both of those JSON files, but they're wrapped into this one configuration object that you can access and toss around and do whatever you need to with.
Interesting. So is it like, does it merge the values, or does it like override? Like if parameter one, if configuration 3 have something that doesn't have in configuration 1, then it kind of overrides. But if there's things that are in both, who is there someone who dominates, or do they just merge?
I believe that it throws an exception if there are conflicting keys.
Okay. You cannot.
I'd have to go back and check that. What's that?
You cannot update?
Not actually. Let's try it. Let's change it and see what happens.
Okay.
Let's go to.
I'll tell you why. This is one design pattern that I use a lot. Like when I use configuration files, that some of them relate to database parameters. The other one relates to something else, and I want to merge them, but I want them sometimes to override some default values.
I see.
So
okay,
if
so
you can do this, then usually what I do is merge dictionaries. But if you do something else, then I'm curious.
Well, let's check it out. So I just changed these. Now we have conflicting keys as CF1R2, CF1R2.
It's the same value? Give it.
Yeah, let's change this value. Let's do it -999, just for fun. And now let's reload these. And I don't see an exception there. So it looks like what happened was it preferred the second key. Now,
second meaning of which config? The first one?
The sample2.
Sample2. So when you say merge with sample2, 2 overrides 1. Yep. Okay, so this is.
Yeah, it looks like that's the current functionality.
Well, keep it. Like, this is good.
All right, we'll keep it. And I know that, OS, there's a common way of making, directories recursively. And I know that it has this flag that's like exist OK equals false by default. So it'll throw an exception. So maybe down the road, it could be interesting to have a flag that says, I want you to yell at me if I have conflicting keys.
Yeah.
But yeah, for now, it's just, yeah.
For now, so it's like,
cool.
Yeah.
And then the last thing here is, if you're familiar with the Pandas API, I think that's kind of what this came from. There's an in place option. So if we say config1 dot get values, you see those, and we'll merge the other one into this one, but we'll also say, let's do in place equals true. And now let's get the values. And now you see that it just used the existing object and overrode everything. So if you want to do in place, you don't want to pass around another object, that's an option as well.
Okay, in place means it changes the object instead of creating a new one.
Yep, it changes the state of this config1 that we're accessing this merge with method from.
Yeah. Sherry was asking a question. I saw it pop up. She was asking a question about how do you access this Jupyter Notebook? It's in the links that you provided us.
It is. It's got a there's a notebooks directory at the root, and it's got the only cells it has is just these ones right here. So you'll have to write the code below, but it's got the method names here and the value names and all that stuff. So it should be pretty self-explanatory.
Okay, so it's in the repository you gave us the link to, correct?
Yep, that's exactly right.
So Sherry,
and I'll send another link in case it got buried.
Yeah.
Oh, there we go. Thanks, Jeff. Beat me to it. And that's, broad strokes what this thing does. We found it useful for a lot of the stuff that we do. We do a lot of data pipelines. We do a lot of data cleaning, a lot of machine learning model training, write a lot of prediction servers and APIs. So that corner of the world is, where we found the most mileage from this. But your mileage may vary. You might have another use case in mind that we haven't even thought of. If this is something that brings you some value or you want to know more about, let me know and feel free to contribute. But that's the library. Thanks for listening to my spiel.
Okay. Hang around. Well, now we'll have to start exploring this a little bit. So first of all, if anyone has more questions, please unmute yourself. It doesn't have to be specific to the demo. It can be a little bit broader. So jump in, and while everyone is jumping in, I want to explore this a little bit. Let's see if we can get it. So currently what you're saying is that you can translate your files from JSON to YAML. How do you deal with cases where things are your parameters are like tuples, where actually kind of it doesn't work well with, I think YAML allows it, but to some degree, but JSON does not. And also JSON is also not 100%. So those things are kind of not fully interchangeable. How do you deal with the things that are not fully compatible?
Yeah, that's a great question. By default, it'll infer a type, and it'll infer a typecasting function that'll take, the raw input from the command line and turn it into something you think that's presumably useful. So the closest type to tuples is just the list type, and I'm guessing it would read that tuple, see that it had a length more than 0, and it would infer that it's a list. So that parameters reference that we had kind of looked through, if it's listed in there, those are the types that are supported. And if there's something else, I'm guessing it would look for the closest and then just typecast it to what it's familiar with.
Okay. Now let's broaden up the discussion, because you're a machine learning shop, and what you're telling us seems to be far from the magic that people are talking about with machine learning all the time. So I don't know, you can start telling us more about how your world looks like. Isn't really all the time all this magic and nice things that you show, or a lot of the work is a little bit different?
That's funny. Yeah, most of us are, data scientists, machine learning engineers by trade, and the software, the programming, all that stuff came after. So a lot of us, we spend time reading research papers. We spend time noodling and tweaking at neural network architectures to solve some task. But at the end of the day, we're designing these black boxes that take pre-processed data and turn it into something else that we're interested in. And in doing that, we need to build deployable, scalable, MLOpsable solutions. So that means that anything that you get with traditional software engineering and development, we have to do. We have to containerize our deployments. We have to, write Terraform scripts for, allocating resources in the cloud. We try to follow best practices. We have multiple people using Git repos. And the really unique stuff, I would say, it's a surprisingly small part of what we do. It's just a really loud and obnoxious part of it.
Hello, everyone.
So,
can everybody hear me?
I don't know if that answered your question, but yeah, we can hear you.
So, Michael, I have a general question. How much math does one need to know in order to become a good machine learning engineer?
That's a great question. I think we are, as a company, are probably a little more loosey-goosey than other places. Like, I'm sure if you went somewhere like Google and you went through their barrage of interviews and everything, they probably really care. They want you to care about algorithmic complexity and the statistics fundamentals and all this stuff. But we tend to, because what we're doing is really pragmatic, you definitely need to know a baseline set of math. You should be able to read a research paper and understand set notation and, any sort of mathematical symbols that are on a research paper. Typically, you'll want to know what that means, at least from a loose standpoint. But in practice, the things that we build don't require you to have too much of a deep in the weeds understanding. The intuition about data to us is just the really important part. Like if you see that you're building an image classifier and you're getting really poor results, but then you see that you have very few examples in your data set of one class that you're performing poorly on. If you have the intuition that's like, oh, we actually just need to get more data of this class that's really underrepresented. You don't need to know the math behind why that's the case. You just need to have a good gut instinct that's helps you work with data.
So essentially just be data savvy.
Yeah, I'd say that. And you still should be able to, if there's a new research paper that comes out about some evolution in convolutional neural networks or something like that, should be able to kind of get the gist of it. But more than likely, the author has distributed some source code, and you're just going to take some of their open source code and implement it in your application, and won't have to care too much about the nitty gritty. Yeah. Great question. Let's see, what else?
There's something in the chat, I couldn't figure it out, but Sherry was asking, I think.
Let's see. It looks like Nalini was asking about interns. We are hiring for interns. So if you want to send a note to me, I can get you in touch with our recruiter. They are paid internships. We're always looking for good people. So reach out. And I see, the URL, the notebook up there only has 3 cells. Let me double click on that link and check. Yeah, that is correct. We added everything on top of that. So if everyone thinks it's useful, I can just upload, or I can commit these new changes that we've made, and you can have that for reference in the same repo.
Repo has history. You can go away and add this later. It's not a big deal.
All right.
You could go back in history. You can do it later. It's not.
Yeah.
You're always probably trying to follow up. This means people are paying attention. So this is good.
Yeah, that's great. Yeah, if anybody's got any other questions like that are just more generally, what's it like to work at an AI consulting firm, what kind of projects we work on, or, our favorite open source libraries, anything like that, unrelated, feel free, jump in.
Yeah. I'm more. I want more questions about the ArgParse, so maybe I'll.
All right. Yeah.
I'll go. So when you use it, ArgParse, for example, what's the most immediate use case that's like 50% or 70% of your use cases are with this ArgParse that saves you, and how much time does it save you?
That's a good question. There are 2 use cases that are really common. One of them, actually, the general use case is we have some pipeline and we want to change what the black box, the machine learning model, that thing that's integrated into this pipeline, we want to change how that gets rolled into it. So that's training a model, that's evaluating a model, all the pipelines and operations around that. That's the kind of thing that we typically find use from this for. That said, the amount of time it saves us is probably I think it's hard to quantify. It's more of just a feeling. But I think when you see that you have a base script with very few arguments and it's clean and all these other arguments are version controlled and separated, it seems like it helps you fend off a little bit of technical debt, and that baseline functionality stays really pristine and just clean and easy to maintain. So I think it's more the technical debt side of things that happens after, when you keep building and building, and they've written a 1,000-line script or had a repo that they can't manage anymore because it's just too convoluted and bloated out. So trying to avoid that.
Okay, so it streamlines whatever you're doing. It make me tighter and more elegant, in a way that you can later build farther along. So it's like it allows you to build more complex things. It's less about the lines of code and the time it saves you. It's more about the complexity that you are able to increase, to do things that are more complex with less effort.
Absolutely, yeah.
Okay.
And which also leads to a more maintainable code base. We found, like, if you limit complexity a lot, that's the number one thing we always try to do with our repos.
And also standardizes your code. If everyone's using the same library, then eventually it'll be easier to bring in a person and saying, oh, here's the code. And after you've seen one or two, then it doesn't need to, not every piece of code is different. He just knows that everyone uses this dynaparse, and it allows you to, you've seen one, then you know the next few will be the same. So it kind of standardizes everything.
Yeah, absolutely. And it does allow you to add a little bit of flexibility, where we'll often see that some research paper author comes out with a bunch of default parameters for a model that they open source, and it's defined in some YAML file or a JSON file. But then someone over here, maybe a contributor to Torch Vision, if any of you guys are familiar with that, maybe they have the same model re-implemented, but it doesn't have the reasonable defaults. You can use dynaparse to ingest those configs into your script and then pass them into this other implementation fairly seamlessly without, rewriting a bunch of interoperability code or.
Aha, interesting. Okay.
Yeah. Good stuff.
Yeah. Someone is writing something for a beginner. It's a long text. I cannot. What's the question?
All right. For a beginner / intermediate with a general low-level understanding and familiarity of ML, what are some strategies you can suggest to help someone level up and explore deeper waters? I do some mentoring on the side through a platform called Sharpest Minds. And I've found that in mentoring those folks, the one thing that always just, it just makes things click really, really quickly and allows you to learn quickly is if you find something that you're very, very interested in. If you're into plants, maybe you want to build like an automatic watering system or a soil moisture predictor or something like that. Or B, you found another use case that you like Kaggle, you found some competition that, something that's really close to your heart. If your core passion is already there and there's a clear end goal, like you want to get to 90% performance or something like that, you'll figure out all the steps and you'll stumble along the way. But, the necessity truly is the mother of all learning. So if you have a really clearly defined goal and it's something that's close to your heart that you're passionate about, everything else just kind of falls into place from my experience. So I know it's a little generic, but that's what I found to be really helpful. And the mentoring platform link, I can share it. There are a lot of great mentors on there. Let's see, shared. Lots of good folks, and they do this model where you sign on to you can do an income share agreement or whatever, but the mentor is motivated to see you through all the way to the success of your career because there's a little bit of an incentive in there. Yeah, great question. What else? Oh, hand raised. Let's see who that is. Looks like Ian. You have a question? If you're talking, it looks like you're muted.
Can you hear me?
Yep.
All right, how you doing? Yeah, my name is Ian.
Glad to have you.
So I am currently a data analyst intern at Fannie Mae, and I really have a passion for software engineering. So I wanted to know, what is some advice trying to transition into that field from a data perspective?
Yeah, I think a lot of that advice kind of overlaps with the previous answer. It's find the thing, the software application that's really aligned to your core passions and values. And if your passion and interest is already there, then, by necessity, you'll figure it out. That said, I think really taking some time to learn about good design patterns and learn what clean code really means. That book I recommended, I would highly recommend to look at that one. It's just literally called Clean Code. I think it says like an agile handbook for writing good software, something like that. It's Martin Fowler. Working through that book and intuiting the concepts will put you by far and away above, I think, a lot of other folks. And then just getting the reps in, coming to meetups like this, getting familiar with some libraries, contributing. That's another one that's just a great way to learn. Go find any project. There'll be some issues where you can get your hands dirty pretty quickly.
Okay, thank you.
Yep, Uncle Bob. That's right.
Yes. I love this guy. Check out the Uncle Bob, The Future of Programming. Highly recommended YouTube video. I want to go back to the library. We'll
let's do it.
People ask it, but I want to come back. If you want people to start using your library, what's the first thing that you suggest that they will do? You showed the demo, okay, so they can follow the demo, they can watch the video, but beyond that, when do they need it, or the first few steps so they can get familiar? What would you do?
Mm-hmm. Yeah, I think number one is to just get familiar with Parser, the built-in library. That a familiar and an understanding there is definitely important. And anytime you write a script that has arguments, you're going to use argparse in Python. So if you have a use case that pops up where you have that kind of argparse functionality that's required, learn how to use it. Forget that dynaparse even exists for a little bit. And then if you find yourself writing arguments for a script and then your arguments list is getting really long and it's just getting longer and longer, that bloat is probably a really good sign that dynaparse might help you, because more than likely you just have a bunch of dead arguments. You're just adding and appending to this for forever, and you'll realize that you only need some of those arguments some of the time, and the really important core functionality only takes up a small subset of that list that you might have come up with. So I'm hoping that's a little helpful.
Yeah. This is where I was reaching out. But also one more thing, arguments, sometimes you want to do some checks on them. Some libraries allow you, this is mandatory or required, or the value cannot be more than 5 or something like this, or this value must be an integer. Is it something that currently dynaparse can do?
Yep. When you run dynaparse init and you take a config file model to generate a new spec file, by default it'll say that everything is required, and there's a little flag that just says required : true. You can change that, manipulate it in any way you see fit. But yeah, anything that you can do to configure an argument with argparse should be fully functional in dynaparse as well.
Okay.
Yeah, great question. And thanks for taking the notes, Sherry. I appreciate that.
Yeah, Sherry takes many notes. She's one of our regulars. She's been coming to this meetup for many years now.
That's great.
At this point, I see that people are more interested in less about the library, but more about your experiences. But in this case, I'm thinking maybe unless someone has more questions about argparse, dynaparse, or whatever you were showing us the demo, we can perhaps stop the recording. So, any more questions about dynaparse? Going once. Going twice. Okay.
I think it's gone, Jacob.
Yeah, okay, so that's enough about the demo. So first of all, we want to thank you, and I want to show the hands, how they're flying in the air. So I want to thank you all, and please, if anyone is interested in clapping, making some noise, I want to thank Michael. And you see people are pressing the hand button. You see those hands fly.
Thank you. Yeah, thanks for having me. This has been a cool experience, and yeah, really excited to get to know you all.
Okay, wait, stick around. No one go away. I'm just stopping the recording now. We're still continuing here. So